with the quiz problems from quiz 3, the derivatives integrals, some of that just involved the fact that you had to deal with taking derivatives integrals, but I'll start here with number 1. By the way, I had your answers scrambled, so this may not be the same order that you saw the answers in. And yes, I did that on purpose to lessen cheating. So we have f of x given in sigma form. You want to make sure you're clear who's the variable of this function, and that's x. Realize that while sigma has variable n, it's going to roll out and plug in the 1, the 2, the 3, the 4, and make everything that you see that's n be a number. So you want to look at the exponent on your variable because that's going to be part of what you will be taking the derivative of using the full power rule on. But I'm going to put in blue everything else in that formula because that is a constant multiple. So if you're integrating using the sigma itself instead of a few terms, then you're going to, come back to me. There we go. You're going to just bring over the constant multiple and then use the power rule, bring down the exponent, and subtract 1 from the exponent. And from there, you can look for this formula, but it could be a shift of this formula in the formula category. So let's see if, do any of these have that specific formula on them? I'm trying to see everything on one screen and I'm having difficulties. It looks like this formula, and then you can double check by plugging in n equals 1, 2, 3, and so on. When I plug in n equals 1, I am getting 2 times x to the 1 power, and that matches the first term, so I'm feeling pretty good about that. I'm going to go ahead and move on to number 2. For this problem, you needed to first plug in t to the 6th power into the sin x. So sin x is approximately, it's an odd function, so it begins with the odd exponent of 1 and then alternates to subtraction. And you can always look at the format, but I'm just going to throw it at you in the first few terms format. Plugging in t to the 6th power. When I have t to the 6th power, and I'm plugging it into x where it is cubed. Hold on, let me finish the way I'm doing it, and then I'll try and figure out what you're saying. If I plug in t to the 6th into the x cubed, I multiply the exponents to get 18. And then again, plugging it in here, multiply the 6 times 5 to get 30. And if I'm integrating from the center to the variable x, then I'm basically just integrating and using x. So if I integrate t to the 6th, I get t to the 7th over 7, but I'm putting an x in. When I integrate, and I'm going to change the t to an x, add 1 to the exponent and divide. And And after you have a couple of terms, you can see if any of those are matching. That first one is almost matching, but missing its factorial. This one here looks like it might be matching. And yes, definitely. It's the only one with the same first two terms, so it's good to go. And then I'm going to, oh yeah, you had, could you also do a u sub and divide by the polynomial? Oh, with this integral, if you were trying to do it through the actual integrand function, you wouldn't be able to use substitute it. It would only be able to use substitute if, okay, eraser, hello, I called you and thank you for showing up. I get aggravated with my technology. If there was a t to the fifth multiplying, use substitution would work, but without it, you won't be able to fully process into the u sub. So then number 3, definitely tricky, probably took a few reads, and it's telling you the third derivative of f of x. You want the coefficient of the x minus 2 to the fourth term in the fourth degree Taylor polynomial about x equals 2. So let's focus on what it's asking for. It's asking for the coefficient of the fourth degree Taylor polynomial. That means you're looking for the fourth derivative at the center, which is 2, divided by 4 factorial. That is going to be the coefficient that will be multiplied by x minus the center to the fourth power. So it's asking for this. And then you take a look back and you see, okay, well, what do I have to work with? I have the third derivative with respect to x. I need to find the fourth derivative at x equals 2. So that means I'm going to first find the fourth derivative with respect to x, which means I need to take the derivative of this. So then chain ruling, I have 3 halves bleh to the power of subtract 1 from the 3 halves. Shove that baby function in and multiply by its derivative 4. And then I'm going to simplify a touch. So, and I have 6 times the square root of 4x plus 1. And now I need to know when x is equal to 2. And so I get 6 times 3 is 18. But it's 18 divided by 4 factorial to give me the full coefficient. And 4 factorial is 24. And then it's a matter of simplifying to get to the fraction that's there. Let's see, if I divide by 2 and then divide by 3, I get 3/4. Let me see. So there's an integral. We take the exponent. Yeah. To the last chat question. Okay. We are given f prime. We want the first 3 non-zero terms for f. So we've got to think about the integral of this function. Now, we are told that f of 0 equals 0, and we need that in order to deal with the plus c issue. Now, if I'm given that when I plug 0 in, I get nothing out, the fact that the answer is 0 says you can just integrate from the center to the variable. But to do that, I'm going to change this to a t and then go to x. And now I'm going to look at how do I go through that integration process, starting with the known function. So I know sine x, and I'll write the first few terms. And then I'm going to plug in a t squared. And when I plug it into the x, I need to multiply the 2 exponent with the 3 exponent to get 2 times 3 is 6. And again, plugging in t squared, 2 times 5 is 10. And now I'm going to integrate that function. Now let me say this. If I was just doing an indefinite integral and I wasn't really sure about whether it was okay to do the integral from 0 to x, I could throw on a c plus and then integrate. So integrating, I have t cubed over 3, t to the 7th over 3 factorial times 7, and so on. And then if I look at this as a function, then I need to plug in the known when the t is 0, the f of t is 0. So I'm getting basically that that constant must be equal to 0. Or if I integrated from 0 to x, I would see that I plug x in, and then minus I plug 0 in. That constant, if you have it there, will subtract itself away. So either way, we are looking for these terms, but I think probably with an x. So let's see which one it comes out to being. And I think this is going to be the telltale sign. That's not 7 times 3, it's 7 times 6. And so that is matching up there with this one. Because it has both the bottom two that I have are the x cubed over 3, and so it's between those two. Okay. And then this one, we are trying to find the integral of the function f of t. First, I've got to find f of t. Isn't that fun? So, f of t through the Taylor formula is my f of 0 plus my f prime of 0 times x plus, and then the formula kicks in harder, the second derivative over 2 factorial x squared, and then the third derivative over 3 factorial x cubed. So you actually have to first go through the process of the Taylor series, which in this case it's Maclaurin. And now we're going to integrate that. And since it's Maclaurin, the center is 0. So when it's asking me to integrate from 0 to x, I can just literally flat out integrate it. And so that means that g of x, if I flat out integrate, is 3x negative 4 times x squared over 2. And that's just a 1. So I'm only needing to integrate x squared. 3 factorial is 6, and then integrating x cubed. And then it's just a matter of figuring out which one is the same. So that's going to be simplifying to a 2 there. And x cubed over 6 times 3 is 18. 24. Let's see, who matches that? Wait. Did I error? Because I'm not... Oh, I don't have an x to the 4th term in there. Silly me, I was focusing on that one. So I'm looking for x cubed over 18 on the right end, and I still don't see that. Why not? What did I do? Did anyone see an error that I made? For the first 2 terms, okay. Anyone see where something went wrong? Thank you. Oh, yeah, that goes there. That's just that. Thank you. Okay, so then that means this one. So, you know, as you watch me make mistakes, it can make you maybe feel a little bit better when you make those silly errors. They happen to us all. There's some people who are ridiculously good at not making errors. I sometimes call them alien creatures because they seem to come from another planet of, wow, what? Anyway, I should stop.